In today's lesson, we will be continuing with what we learned yesterday about solving for limiting and excess reactants. Today we'll focus primarily on excess reactants. As always, please try and take a minute to solve through this warm-up on your own. Okay, hopefully by this point you have solved for this warm-up on your own. So what we are going to be doing is determining the limiting reactant if we are provided 6 moles of each reactant. So please remember that on the left side here are your reactants. That's what you have available. So these are your reactants, and then on the right side we have our products. So products are what can be produced. So with these, what this reaction is telling me is I need 4 moles of aluminum for every 3 moles of oxygen to produce 2 moles of aluminum oxide. So to determine which one is going to be my limiter, I'm going to start with 6 moles, and I'm just going to choose aluminum. And now in the reaction it tells me that we have 4 moles of aluminum for every 3 moles of oxygen needed. And keep in mind, when you solve from one reactant to another, what that is doing is telling you, alright, if I use up all 6 moles of aluminum that I have available, how many moles of oxygen would I need? So as always, we go through, cancel out our units, and we are left in terms of moles of oxygen. And this will give us an answer equal to 4.5 moles of O2. And as always, I like to go through and label these. Alright, this is how much aluminum I have, and this is how much O2 I would need. So since I need 4.5 moles of O2 to use up all 6 moles of aluminum, and I know because it told me up top here I have 6 moles of each reactant, so this is also telling me I have 6 moles of O2, but I only need 4.5, so therefore we know that oxygen is in excess, and that is going to make my aluminum my limiting reactant. You've already seen this slide multiple times throughout this unit. I just like to put it back in here so we can reference it throughout this lesson. This slide again is just a description of what I talked about with the warm-up. So in order to find the limiting reactant, we find how many moles of B we would need to react with all of A, and then we find out how many moles of A we would need to react with all of B. So that's what you're doing when you solve from one coefficient of another, is telling you to use up all of the reactant A that you have in the world, how much B would you need? And then you do the reaction the other way. Well, to use up all of the B I have in the world, how much of A would I need? So you compare the amount needed to the amount available, and whichever compound has more available, so whichever you have more of, compared to what you need is going to be your excess. And then just quick reminder down here, your limiting reactant is the reactant that runs out first. Your excess reactant is the reactant that you have left over. And now here's going to be another similar example to the warm-up problem, except for here we are going to take, given 6 moles of each reactant, determine the limiting reactant and excess reactant. And we're just working with a different equation here. So now I have 2 moles of hydrogen, 1 mole of oxygen for 2 moles of water produced. So if we go through and solve for this one, I take what I have. Well, I have 6 moles of H2. And then we look at our ratios because, again, if we go back and look at those circles from that reference page, we just look at our coefficients. Well, I have 2 moles of H2. Oops, sorry, let me switch my pen here. I have 2 moles of H2 for every 1 mole of oxygen. So 2 moles of H2 for 1 mole of oxygen. So what this is telling me is that to use up all 6 moles of hydrogen gas, I would need 3 moles of O2. So realistically we could stop here because I now know that I have more oxygen than I need because I have 6 moles, but I only need 3 moles. So hydrogen is going to run out long before my oxygen does. But just to double check our work, let's go through and solve the other way. So now we're going to start with our 6 moles of oxygen. I know that I need 1 mole of oxygen per 2 moles of hydrogen. And we are going to get an answer equal to 12 moles of hydrogen. So that's telling me to use up all of the oxygen, I would need 12 moles of hydrogen. But we know that we only have 6 moles. So then we can go through and fill this out. So remember, 6 moles of both are available, so since 12 moles of hydrogen are needed, only 3 moles of O2 are needed. H2 is going to be our limiting reactant. Alright, so given 121 grams of aluminum chloride and 23 grams of lithium, determine the limiting and excess reactant. As always, please go through, try this one out on your own before we begin. Okay, hopefully by now you have tried this problem, so let's go through and solve for this. So again, the problem is telling us that we have 121 grams of aluminum chloride and we have 23 grams of lithium. Please double check, make sure your equation is balanced, which in this case it's already balanced for you. So we go through and look at this. And we have, I'm just going to start off with 23 grams of lithium. Again, you can choose whichever one. Doesn't really matter, but in this case, I chose to start with lithium first, which makes lithium my A. Now we're doing our steps where we go from grams of A to moles of A. And again, this is, as always, referencing the slide that you've seen over and over with those circles. Then our next step will be to go from moles of A to moles of B, where B in this case is aluminum chloride, going from moles of B to grams of B because that's what all of my units are in, so that's what I'm going to have to be comparing. So for this first step, I'm going to do my step number 1 here, which tells us that we need to look at our periodic table. So my periodic table tells me that the mass of lithium is 6.94 grams per 1 mole. Then we do our second step, which tells us our coefficients, or to look at our coefficient. Well, in this case, my coefficient of lithium to aluminum, or aluminum chloride, is going to be 1. Realistically, there's that 1 there, to 3. So I'm going to have 3 moles of lithium on bottom and 1 mole of aluminum chloride on top. And now we do our third step, which is just looking at the periodic table again, looking at the molar mass of aluminum chloride. So that's 1 aluminum plus 3 chlorine, and that gives us a mass equal to 133 grams of aluminum chloride per 1 mole. And if we do this, we find out that in order to use up all of the lithium that we have, we would need 147 grams of aluminum chloride. Look at that, when we compare these two numbers, so if I take these and I compare, I know I have 121 grams of aluminum chloride, but I need 147 grams of aluminum chloride. So that's already going through and telling me that, hey, my aluminum chloride is going to be my limiter. Alright, now we're going to solve this problem again, but this time we're going to start with our 121 grams of aluminum chloride, and we're going to convert to grams of lithium. So again, whatever you start with is your A, and whatever you are solving to is going to be your B. So we're going to go from grams of A to grams of B. So starting off, we have 121 grams of aluminum chloride. There are 133.3 grams of aluminum chloride per 1 mole. There is 1 mole of aluminum chloride per 3 moles of lithium. And there is 6.94 grams of lithium per 1 mole. And if we do this, we will see that we need 18.9 grams of lithium. But again, comparing our values here, we have 23.0 grams of lithium, but we only need, in order to use up all of the aluminum chloride that we have, we only need 18.9 grams of lithium. And that would make sense. This is a good way to double check your work because we already solved in the last problem that aluminum chloride was our limiter, so therefore lithium should be excess. If for some reason you ended up getting a number here larger than the amount of lithium available, so let's say for example you got some answer equal to 25 grams of lithium needed, you would know that you made a mistake because for both you would need more than you have. To put this problem in word form, down here we say that since we need 18.9 grams of lithium and we have 23 grams, lithium must be our excess. In many problems, it will ask you to solve for how much of the excess will remain unreacted, or how much of the excess will you have left over. Well, to do this, you take what you have and you subtract what you need. So you're saying how much do I actually own versus how much is needed for the reaction to occur. Well, in this case, we know that we have 23 grams of lithium because that's what the problem told us we were starting with. And then we subtract how much we needed. Well, we didn't need to use all of our lithium because it was in excess. We were going to have extra of it left over. But we were using up all of our aluminum chloride. So we subtract how much lithium we actually need to react with all of our aluminum chloride. So how much lithium we used. Well, in the problem we solved that we needed to use 18.9 grams of lithium to use up all of our aluminum chloride. So we're going to have lithium left over. And in this case, we are going to have 4.1 grams of lithium left over. By now, you should have enough information at your disposal to be able to go through and solve for this problem. So please take a minute and try and do this one on your own before watching the video explanation. Okay, hopefully by now you have tried this problem on your own. So given 24.5 grams of magnesium hydroxide and 14.2 grams of potassium metal, determine the limiting and excess reactant. First thing you should always do with any problem is make sure that it is balanced. So looking up top here, you'll notice that we have 2 hydroxides on the left, but we only have 1 on the right side. So we need to go through and balance this. So we're going to add a 2 here. That's going to give us our 2 hydroxides, but that also gives us 2 potassium. So we're also going to have to add a 2 here. Now our reaction is balanced. And then we want to go through and determine, well, what all do we have? So we know that we have 24.5 grams of magnesium hydroxide and we have 14.2 grams of potassium metal. That's what we own. So in this case, let's go through and start doing one of these problems. So we're going to solve from one reactant to another. In this case, let's just go ahead and start with our magnesium hydroxide. So magnesium hydroxide in this example is going to be our A. This is what we're starting with. And we're going to convert to our potassium, which means potassium is going to be our B. So going through and solving for this, our first step tells us we need to find the molar mass of magnesium hydroxide, which is 1 magnesium plus 2 oxygens plus 2 hydrogens, and that gives us a molar mass of 58.33 grams per 1 mole. And then we need to do our mole to mole ratio of magnesium to potassium. Well, looking at our equation that we balanced, you'll see that we have 1 magnesium here to our 2 potassiums. So in this case, we have 1 magnesium hydroxide to 2 moles of potassium. And then we have to do our third and final step, which is going to be our molar mass of potassium. So there's 1 mole of potassium per 39.09 grams of potassium. And that gives us a final answer equal to 32.8 grams of potassium. Now again, this is telling me how much we need. So to use up every last bit of magnesium hydroxide that I have, I would need 32.8 grams of potassium. Well, look at that. The problem already tells us we only have 14.2 grams of potassium. So right away, we know that our potassium is limiting our reaction. Well, let's go through and solve for potassium in this case. And we are going to solve for, this is going to change our A and our B. So we're going to start with our potassium. So potassium is now going to be our A. And magnesium hydroxide is going to be our B. So we start with our 14.2 grams of potassium. We use our same molar mass that we found in the last problem. So 39.09 grams of potassium per 1 mole. There are 2 moles of potassium per 1 mole of magnesium hydroxide. 1 mole of magnesium hydroxide is equal to 58.33 grams of potassium or magnesium hydroxide. And you will see that in order to use up all 14.2 grams of potassium, we would need 10.6 grams of magnesium hydroxide. So what that means is we have more magnesium hydroxide than we need because we have 24.5 grams, but to use up all of our potassium, we would only need 10.6 grams. So therefore, we know that this is our excess. We're going to have extra of it left over, and this was our limiter. As always, please take a moment to try these two problems on your own. Alright, hopefully you have tried these problems on your own. So, as always, first thing we need to do is make sure that we have this reaction balance. So we have 1 magnesium hydroxide per 2 potassiums per 2 potassium hydroxides per 1 magnesium. Now, what this question is asking us to do is determine how many grams of magnesium metal can be produced. So in the last problems, we always solve from one reactant to another. Now in this case, we're going to actually solve from one reactant to a product. So our reactant that we're going to start with is going to be our potassium. And the reason we start with potassium is because it was our limiter. Limiter meaning it is limiting how much of our products can actually be produced. So here we're going to start with our A, we're going to start with our limiting reactant because it's the one that's going to run out first, and we are going to solve for our magnesium because that's what it's asking us to solve for. So when we go through and do this, we're going to start with what we have, and in the last problem we saw that we started with 14.2 grams of potassium. And that was given to us directly in the problem. So we start with our 14.2 grams of potassium, and using similar steps, we're still going to look at our molar mass. We're still going from a grams of A to a grams of B. We know that there's 39.09 grams of potassium per 1 mole. There are 2 moles of potassium in this case for every 1 mole of magnesium produced. And then 1 mole of magnesium is equal to 24.31 grams of magnesium. And going through and solving for this, we see that we are able to produce 4.42 grams of magnesium. And then the last part of the question is asking us to determine how many grams of excess reactant we will have left over. Well, we did a similar problem to this earlier. So to do this, we have to take what we have minus what we need is equal to what we have left over. Well, we determined that our excess reactant was our magnesium hydroxide. And looking back at the last slide, we know that we have 24.5 grams of magnesium hydroxide. That's how much we started with. But to react with all of the potassium that we have, to use up all of our potassium, we only needed to use 10.6 grams of magnesium hydroxide, which means that we are going to finish with 13.9 grams of magnesium hydroxide left over.